Okay, welcome back. Again, I am Chris Brown, the Ops Tech Alliance Chief Technology Officer. And this video is going to be about Wireshark session replay, kind of. That's at least the demo we're going to get into. Of course, we have to touch on the fundamentals of packets, frames, and whatnot. We'll go into some Wireshark specifics and filtering techniques, and then we will replay a PCAP. And then we'll also demo how to edit a PCAP or edit packets and then replay those edited packets. So it should be pretty fun. Okay, you can't take a computer science course or class or video or anything without talking about the OSI model, right? I assume you've heard this time and again, but let's do it for posterity's sake. All right, so a couple of models that we reference all the time, TCP IP model and the OSI model. Both have their purposes. The way I like to think about it is the OSI model is for when I want to get specific. I want to get very detailed on how something is working end to end. And then TCP is when I'm trying to explain things at a little higher level, not as many details needed, and I'm trying to articulate like kind of what I'm doing or how I'm doing it generally. Everybody's got their own mnemonics. I have forever known, please do not throw sausage pizza away, for remembering the OSI model. Actually, it's like one of those things that I just can't articulate the OSI model without thinking of that. Just kind of like when I use a wrench, or I turn a screw or something, I always have to tell myself, lefty loosey, righty tighty. It's just one of those things. All right, protocol headers. So within each layer of the OSI model, each protocol has its own headers. It kind of gives you some information about what it is and what it's doing. So I always think of frames as a series of envelopes or envelopes, depending on where you're from. And each envelope has a little more detail. It has a detail about what's inside and where it's going. More about where it's going than what's inside, but we'll get into that. Sorry, skipping ahead a little quick here. Let's go for it. Let's get to the demos. All right, so the things articulated, the bytes articulated in red here are Ethernet frames. The blue is an IP packet, and the green is a TCP in this case, segment. And we'll have an example of UDP packet here, or UDP segment, I guess, here in a little bit. From the MAC header, so the Ethernet frame, technically, what we're looking for is the MAC addresses, destination and source, followed by what I like to refer to as the next protocol, like what's in the next envelope. So in this next envelope, we can see IPv4 by the representation 0800. The more you look at it, the more you can just see it without having to break it out or look it up. So, there's particular headers or bytes that you're going to be looking for, referencing often enough that you're just going to know what it means and where to look. Okay, and then within that next envelope, the blue packet, the things I'm really looking for are the destination and source IP addresses, right? So we're one layer deeper. So we're from media access control layer to the IP layer, or the networking layer looking at IPs. And so, again, I've got my destination IP, my source IP, and then next protocol, right? So TCP or UDP in this case. 06 is the protocol. I'm wiggling my mouse here. I hope you can see it. But 06 there, kind of in the middle of the packet, is that next protocol, and 06 is TCP. So let's look at that. All right, and then finally we've got the TCP segment in green, and that tells us primarily what I'm looking for here is the ports. So with the combination of the IP packet and the TCP segment, so I've got the IP addresses and the ports, destination and source of both. So that gives me my socket. Now I have something to work with. I know I'm trying to figure out like the direction of comms and who's sending what where. And that's pretty much it for addressing, at least at this level. We're going to stick to the bottom layers here of the OSI model. We're not going to go up into application or presentation or anything like that. And then just as a quick reference, here would be a UDP header. And again, so we get the port numbers, destination and source, the length of the UDP packet, and then a checksum which exists. It's connectionless protocol, so it doesn't really have a whole lot of meaning, but as you know, is good for low latency stuff, or like stuff that can tolerate loss. All right, I told you we're going to fly through these slides this time. I keep promising we're going to go quick and then end up going long. So we're going to actually fly through these ones, get to the demos. Okay, first tool that we're going to talk about is Wireshark. Wireshark is great for me. I like colors and being able to see things in a GUI. It's not always necessary, but there's some cool functions built in that really help me narrow down what I'm looking at faster than other tools. The ways that we can filter Wireshark collection or Wireshark looking at packets more broadly is we could do a collection filter, so we can filter what we're collecting and saving, or we can do it post collection, so we can kind of keep a broad collection aperture, let's say, and narrow it down in display. So we could collect everything and then display only what we want to help kind of carve out what it is we're looking for. The problem with that display filter or post-collection filtering is that you're going to have a ton of data. There's going to be a ton of stuff that you probably don't need. Networks are noisy, especially the good ones. So, obviously the more you can narrow it down with your collection filter, the easier it's going to be for you to analyze in the end on the other side, right? The caveat is that you might miss something. So I guess my technique is typically to start with collecting everything and using display filters to figure out what it is I'm actually looking for, unless I have very clear, explicit instructions to begin with. So I'll start with the aperture wide open, I'll collect everything, and then display filter, and then maybe recollect if it's not a timely issue or I have time to continue to collect, then I can adjust the collection filter to really narrow down what it is that I'm trying to save and work with in the end. So each has its pros and cons. It kind of depends, obviously if you had all the resources and what you need, then you could do both. You could be running a wide open collection and a more narrowly focused one, and kind of update on the fly. Yeah, again, it depends on what you're looking for and what you're trying to accomplish and how much you already know. There is an alternative to both of those, and that is just putting your tap in the right place, like only collecting from where you expect the intended target to be, or the traffic, I should say. Not always very clear option, but worth mentioning, I suppose. Okay, and then filtering works at a bunch of different layers. So the internet is your best resource because there's a bajillion of them. I think technically a bajillion. I'll throw a couple slides out here just in case they come in handy, and maybe some of the more common and simple ones. But again, like you're going to build, each filter is going to build on the different layers, and you can really use your logic operators to refine what it is that's either displayed or collected. So here's some filters you would use at the data link layer. CDP is near and dear to my heart. I like that one a lot. It has a ton of information in there that isn't maybe obvious, I guess. Anyway, there's like the iOS, so CDP, well, I guess I should define what it is. Cisco Discovery Protocol. It's used for core routing of Cisco, Cisco router implemented. There's 2 versions of it, doesn't matter. But it contains a ton of information, like the hardware platform that it's running on, what iOS version is running, the hardware capabilities. It gives a lot of addressing information, and that's Cisco's edge routing or core routing discovery function. Like, hey, here I am. You can use me for routing if this all makes sense. But if you're into different things, and the hardware platform and the iOS version number could be useful to you, then that's one way to discover that without having to ask. So it's a broadcast. It's typically implemented by default. It is implemented by default, or at least was when I cared about it more, and gives you an abundance of information that could prove useful. It's not necessarily a hint, just I find it interesting. All right, and then at the network layer, again, these filters look really obvious and easy, and they are to an extent. I'm just going to go to the next slide because it gets a little bit more interesting when we're searching within protocols. So, and these are simple router announcements. Again, like great wealth of information in router announcements. ARP messages you can find, MAC to IP resolution, stuff like that. And then services or like transport protocols, you could narrow it down to a particular protocol that you're looking for, like FTP or Telnet or HTTP or whatever it is that especially if you're looking for like plain text credentials, you could narrow it down to services that are plain text, or eliminate ones that are not plain text. Speaking of credential recovery, that's a fun one to do. So probably one of the more useful places to start when I know nothing else, and I'm maybe trying to gain initial access, would be frame contains. So frame contains and then a string in quotes. So beyond seeing what services are running or what services are being used on the net, and then trying to figure each one of those out, I could just look for the word password or pass or user or login or something that gets me close, and then I can iterate through the packets around there in that protocol that maybe give me more information. So we'll see that here when I bring up Wireshark in the demo and see what that looks like. But frame contains is just a broad search for strings that you would otherwise find in there. You could do the same thing with your PCAP and the strings command. It's just like, if I already have Wireshark open, let's use that, and then it affords me the opportunity to like trace that stream or some other fun utilities. Okay, bottom line, lots of useful filters. Like, you're really trying to narrow down what you're looking at for resource constraints. Like, if we had all the compute power in the world, which I suppose is more and more achievable these days, but like you want to try to limit what it is you're looking at so that it's relevant. You're not wasting a bunch of time digging through millions of packets to find one thing. You're able to carve it up such that it kind of manifests and presents itself to you with less effort on your end. Let the computers do some of the work. And then another reason for this, so we talk about carving it up, filtering, and especially like display filtering. One thing that I'll do is I'll really narrow down what it is that I'm looking for, and when I find it, I will extract those packets only, and I'll show you how to do that in Wireshark. They make it really easy, which I love and appreciate. But the benefit to that is that I don't have to remember or capture what the filter was necessarily, because I've already extracted those packets into a usable format, like a separate PCAP for either evidence collection, or I can organize it in a way that makes sense, just as any other file, as opposed to having to rerun filters on this massive data set and try to get to the same thing, hoping that I didn't, forget one of the filter criteria that ends up giving me a different result. All right, let's see if we can get over to the demo. Oh, naturally. Took too long talking, see? All right, let's get in here. We've got our Kali instance here. And what I've done is I've opened up, I'll show you what I've got. I'm just in my home directory in a PCAP folder that I made. And the only thing in it is this is a raw telnet session. So unencrypted raw telnet session. It's an example out of the Metasploit framework, one of the Ruby gems. Doesn't matter. In Kali, there's a bunch of example PCAPs. I just borrowed one of those. I copied it over my home directory so that I have permissions to work with it, but there it is. Okay, so I've opened that up, and you can see here we've got some, again, I like Wireshark. It kind of like makes everything pretty colors and it extracts a lot of the information, and I can drill down as needed only. I don't have to read hex and try to remember what 06 is, IP, and all that. First things first, this being a targeted file already, like it's already been extracted to be a telnet session. It's not a bunch of other stuff. So it's good that I can look at all the packets, but if I right click on any of them and then I follow this TCP stream, it reconstructs this for me. So I can kind of visualize what's going on in chronological order. And I can very quickly see that I have a login, username and password. So telnet echoes back most things, like the commands, any non-secret thing. So what you're seeing here is anything from my client is in red, and anything only from the server is in blue. So again, it echoes back, so you have to kind of read this a little bit different or carve it up different, which is easy enough to do. Anyway, again, so we see login, we see password, we see the actual password is user, which is something. But one of the cool things, and the reasons I like doing it this way, is instead of having to dig through all the packets, I can already see what it is. But if I couldn't, if it was a little more, it was trickier than that, or if I need to later reference a particular frame number, I need to get there. I need to know which frame this is. So if I click next to the U, it takes me in my window over here to frame number 58, and that's, you can see data U. So that's pretty handy. I can jump around as needed, right? So me sending F to the server is here, and then me sending U to the server is 58. So neat way to get to the frame number. Now, important to note that Wireshark starts counting at 1, and again, this is a already carved up PCAP, so there's not a bunch of extraneous stuff in there. So it's not necessarily true that in a wide open aperture capture that it would be telnet. Like if you were to filter on telnet only, it wouldn't necessarily be frame 58 of the telnet session. So just kind of depends. You got to keep track of that. But this is a pretty awesome way of doing it. And then, okay, so I showed you how to follow the stream. That's neat. Frame contains is, again, one of my go-tos, and it is case sensitive. So, but pretty darn handy, right? So again, we're trying to get to the general area. Okay, so frame 56 is where I start seeing password. That's good to know. Like I want to look at frame 57 and 58 and see what I see. Again, just another example would be log in. Okay, and there's a couple there, so that gets me in the right general vicinity also. Okay, and then even more like higher level, I guess. So if I want just the telnet session and not all the TCP ACKs, I can just type telnet for the protocol, hit enter, and it sorts that. And what I mentioned in the slides is that Wireshark makes it really easy. So when you're building these display filters, you can get it really narrowed down to what exactly it is you're looking for. Say I want just this, and then I can export that. So I can export specified packets, and that sounds really obvious, but the cool thing is I can select between selected, captured and displayed, and then all of these variables here. So I can mark packets, I can do just the login information, I can highlight them and export them. I know this is like day one kind of stuff for file manipulation or word processing or something like that, but like not as simple to do from a command line PCAP capture. So Wireshark provides a very simple way of doing this. All right. So that's Wireshark, that's looking at packets, and you have seen this saved PCAP here, this telnet raw PCAP. What we're going to do now, I've got my notes over here so you don't have to watch me type it all out and spend that time. We're just going to replay it. So how do you replay a packet capture as is? So one is to do TCP replay. So TCP replay is, as it sounds, replays a packet capture at arbitrary rate. So there's a bunch of, I'll let you dig into the man pages for it, but it is not loaded into memory unless you define it. So it's kind of like streamed in, and that has some variability, which is often a great thing in the timing. So it has some variability in timing due to that. It's not a quick burst necessarily. So I already caught my first error on the first command here. One sec. I'm dealing with my interface, so I have to sudo. And before I do that, I want to set up Wireshark to capture. Okay, let's close what I'm doing here. Getting ahead of myself a little bit. Okay, we're going to start a new capture on my interface, and we can see, you're going to see some real traffic here, but not much, hopefully. I'm going to kick off this TCP replay of that telnet raw file. And again, it takes a little bit because it's not loaded into cache, or it's not loaded into memory. It's not cached into memory, like ready to blast out. There's no delay, though you can set a delay. There's a ton of options and switches here for TCP replay, but again, like a basic demo here. So we are going to wait and let it roll out. It should be 272 packets that get sent if all goes well. Now, the number of frames will be different because you're seeing real traffic MDNS stuff come across that same interface while I'm replaying. So the Wireshark is capturing whatever's coming over that interface, not just my replay. So while 272 packets are from my replay, the rest are going to be from real traffic here. Okay, there we go. There's our success message on the command line. So I'm going to stop my capture. And again, like we're over 272 because some real stuff was going on. Nothing fun, so not worth pausing the video for. All right, so and if all went well, then I should be able to do the same thing and get similar results, right? So I've clicked on a telnet packet, and I want to follow that. And what I should see reconstruct is about the same as what I saw earlier. So fake user still, right? So login fake, password user. And so we got the same thing. But instead of this being that saved file, this is what came over the wire. it's virtual wire, but you get the idea, right? That's what I replayed. So I was able to replay all that. Now that's cool, but not necessarily super handy. So what would be more handy is if maybe I could modify some of this to my liking, right? To do something that I needed it to actually do. So we're going to use a different tool called Scapy for that. And if I pronounce it different than you know, that's fine. We can all coexist. Let me clear my session here. Let me actually exit. Sorry, I was making sure my demo worked. Right. Wait for the internet. Come on, baby. All right, I got another tab here. Let's see what I got. All right, so again, all I have in this directory is the telnet raw PCAP. I'm going to run Scapy from that same directory so that I have access to those files easily. Again. And then I'm just going to run Scapy. And so the first thing I could do, I'm going to walk you through the first one because it's kind of neat. What you could do is iterate through. Let me go over to the raw PCAP, right? So if I just like run ahead on this PCAP, it's not readable, right? It's not in ASCII, right? So you could do some stuff. You get some strings. You could get some information, neat, but it's not really usable, or it's not as usable as if you were to load it into Wireshark or something like that. But we could get some information too from the command line. Say we don't have access to Wireshark, and all we can do is like download and install Scapy for some reason. Okay, so I'll walk you through this first one. You can see my notes on the side here, so I'm not hiding anything from you, but I'll type it out here. From Scapy, import everything, and then we're going to define that our packets, we're going to read in a capture file that is called telnetraw.pcap into the variable packets. And now we have that to use. So this is just like a Python program, right? So we're just able to run it in memory here. And then, so now that I have packets loaded, I can iterate through them however I see fit. So what do we say? 50, I think 58. I'm going to be one off. Let's see what we got. Okay, yep, we nailed it. All right, so here we're able to see a much better representation of packet 58 than if I were to run a strings on it, or more it or grep. But importantly, what I could see, well, there's a lot of important stuff here, but it's broken out by envelope. And then I have the raw data right there. So again, in Telnet, you send a character, it echoes, you send a character, it echoes, or not for some things, but point is there's echoing. And all right, so what if instead of the password being user, it was we can make it anything. Let's just go with my example as I have it here. Packet's 57. So, and then so I've got the packet, and then I define what I'm, you're kind of constructing this, you're constructing this to change a variable, or to change a value, sorry. And so we're going to change the U to a 9, right? Which, again, use your imagination what you could change it to, or how you would actually do this. But as far as silly examples goes, this might work. So password. So we're modifying the password, and I'm going to write this PCAP. I'm going to write this capture file as modified password PCAP. My variable packets is going to end up being that PCAP. Okay, so if I then run over to Wireshark, because it's easier for me to see, I have to iterate. I could just open up this modified password PCAP. Follow that TCP stream, and we should see a different password. Okay, there it is. So we effectively changed the U to a 9. Again, how useful is that? I don't know, but you get the idea, and you know you got to use your imagination a little bit here. But you could carry this on to change whatever it is you want. So another example, I'm not going to make you watch me type it all out. I'm just going to copy and paste it. But like, so you can not only, so this next example, we're going to modify the source IP on all packets. So I want to do this on every packet. Again, you can use your logic to change just what it is you intend to change, but we're going to modify all packets on this example. And then, and it's not going to be incredibly useful, but again, use your imagination. You can see like the utility of it, I hope. Then we're going to write that. Yep, hang on one sec. We actually want to, I'm going to start over, I want to write it out. So the checksums. So if you're changing like source and destination IPs, or some of the more critical fields, especially the from, you're supposed to copy properly. From. Okay. Oh, come on. All right. So I should have just recopied it, but we'll get there. Bear with me. All right. Before I hit enter, because I believe it's going to work this time, the checksums for some things, like we didn't have to do it for the raw data. Maybe on the addressing stuff we want to redo it. All you have to do is delete the existing checksum, and Scapy rewrites when you write a capture file or replay, it will recalculate the checksums. So that's really handy. Again, I like the computers doing the work. All right, so we wrote out modified IP, PCAP, and we're going to do kind of the same thing here. We're going to go to Wireshark, open modified IP, and you can see the source IP changed on every packet for, well, hang on, let me clear my filter here, see. Changed on every packet. Now that's not helpful because you know our acts didn't come from ourself, but again, you could use logic to do that a little more properly and make it actually do what you intend it to do. But hopefully that demonstrates the utility of Scapy, and that is how you that is one way of modifying packets and replaying. So again, like we would just go through the TCP replay of our modified PCAP to replay that PCAP as modified, right? Okay, so that's it. Hopefully that was useful and you learned something, or a different way of doing something that you already knew how to do. And you know, hopefully it was useful. Let's see if I can get back to my thing here. All right, and that was the end of it. That's the end of the demo, and I have no more slides, so have a lovely day.